Hello everyone, welcome to Gate Academy Global. In today's thought-provoking video, I am going to discuss about the current across the capacitor. As you guys are well aware, the capacitor has been filled with a dielectric material, and the dielectric material has been a kind of insulator. And if you apply the external voltage between these two terminal and which has been filled with the insulator, there should not be any current. The IC current should be zero. Whereas widely you use one formula, IC is equals to C dVc by dt. Either you take the reference of analog, either you take the reference of network. And end of the day you say, sir, I had been mastering of transient analysis. I can solve almost all problem related to the RC, maybe RLC. But end of the day, you yourself are not knowing how there had been the current across the capacitor which had been filled with the insulator. My today's topic is been based on the thought-provoking concept of current through insulator, and end of the day we will also deduce how there had been the current across the insulator and how did you get the current across the capacitor. IC is equals to of C dVc by dt. What I feel the basic problem is been the way you had started the concept of current itself. From class 10th onwards, you were knowing only and only one current. Which current that was? Where the charge flows across a conductor because of external electric field or external force of V, and there has to be a current, and there used to be a current. My dear friend, that current was a conduction current. And keep in mind that is not only the current. There are several more number of currents where the charge carrier might not be flowing, but still there had been the fundamental of current. You can take the reference of diffusion current, which you see in case of diode, which you see in case of non-uniformly doped semiconductor. There the charge carrier do not move, but still you found a current, and that current is being nothing but diffusion current. Similarly, the another kind of current is being a convection current. You can take an example. Let's take this has been a two pulleys which has been injected with a rubber strip, and if the rubber strip is being spreaded with a charge carrier, and let's take if one wheel is started rotating, so because of that rubber strip is going to move forward, and because of movement of rubber strip there had been the movement of charge also. And if you take a small ring, you will see there had been the movement of charge carrier inside the ring. There had been the flow of current across the ring, but that is again not been the conduction current. There had not been external electric field. There had just been a convection or the movement of structure. And the same thing also do exist with the insulator, and that type of current is being the displacement current. So forget about the current which you had studied so far. There are several more number of currents. And if you stick to the current which you had studied, that's been the conduction current and its related laws, which is we call Ohm's law, V is equals to IR, there would not be any current across the capacitor. Why? Because V is being I into R. And let's take if the R is being taken infinity, there should not be any current. My dear friend, if I say the Ohm's law, the aura of the Ohm's law is just been maybe 4 to 5% of the complete electrical engineering, because Ohm's law will not be able to decide all of the current and voltage relationship, and the capacitor inductor are being the part of that. You will not be able to deduce, you will not be able to derive, you will not be able to connect the voltage and current equation or relationship with the help of Ohm's law. You can say it's been the failure, but no issue. What we had been doing, we have been moving forward. My basic motivation is to get this formula derived. What I did, I had taken a reference of parallel plate capacitance, where we have got a two conducting parallel plates. Let's say this has been the first plate, this has been the second plate, and their cross sectional areas are been A. And the material which has been filled inside, it's been a type of insulator. Actually, all insulator cannot be used in between the capacitor. Usually the dielectric materials are being used. Dielectric materials are being a kind of insulator, but not all insulators are being dielectric. That you have to keep in your mind. And let's take their perpendicular distance between the plate is been D. Now what I did, the external voltage V is been applied, and as the external voltage V will apply, what will happen at very starting, the upper plate and lower plates are being electrically neutral. What does it mean of it? That means in each atoms, the number of electrons and number of protons were same. But what had been happening, now because of external battery, external force, the electrons would be attracted, and as the electrons are being attracted, there would be the deficiency of electron in each atoms, and because of that, there would be the deficiency of electron, and as there had been a deficiency of electron, it would become positively charged because now the number of protons are been more. So this becomes positively charged plate, and now this electron all the way had been supplied towards downside, it would become electrically negative plate. Negative plate. Now, if I wanted to know the current across the capacitor, my dear friend, one thing has been quite sure, because the dielectric material which has been filled inside had no conduction at all, so you cannot even thought of having a conduction current, like the electrons are moving from one plate to another plate. No, you can't have that. So the conduction current density is being completely ruled out. So sir, then how the formula had come? Anyways, the formula had come from our great mathematician, I would say, after Newton, after Einstein, the person who had contributed most critical concept over the physics, and that's been the Maxwell. What had happened? As per the Ampere's law, the closed line integral of H dot dl was I, and the I which the Ampere was referring was conduction current IC. But when the Maxwell was consolidating all of the four formulas and correlations were built, he got to know this formula has been little bit incomplete. So what he did, deliberately he had put the current ID, displacement current density. And one of the worst thing was, he did not have any experimental proof of ID. So in that era, most of the scientists were scolding to Maxwell like anything. They were saying that you had touched such a beautiful equation, the equation which has been crafted by the renowned scientists of that era, and now you do not have any experimental proof. But how the ID was defined? ID was defined as A, that's been the cross section area, rate of change in electric flux density. Anyways, one thing has been quite sure. Forget about this. Within the capacitor, you are not going to get the conduction current because the conductivity sigma within the material which has been placed between the two parallel plates are been 0. So only we can have a hope from A dou d by f dou t. See what had been happening. Once you apply a potential difference between a parallel plate capacitor, inside the parallel plate capacitor, the electric field intensity remains uniform anywhere at any space you see. And that had been defined as a E is equals to V divided by FD. I am not going into the detailed part of it, because the electric field intensity is not always uniform. If you take the reference of spherical capacitance, it's not been uniform. If you take the reference of cylindrical capacitance, it's not been uniform. But in case of parallel plate capacitance, it's been uniform. E is equals to of V by D. Yes. Now what had been happening? So electric field intensity within the capacitor has been taken as E is equals to V divided by FD. And as we know, the electric flux density has been directly proportional to the electric field intensity. And as it had been happening, my dear friends, now the D could have been taken as epsilon into V. ID is already been taken as A dou d by f dou t. And may I know what had been dou d by f dou t? See, epsilon had come over here, E is been V divided by f d. As far as the differentiation of this complete terminology is being concerned, this term is going to be a constant always, because once the capacitor is built, the material within the capacitor, which is a dielectric material, is not going to change. Its permittivity is not going to change. Not even their plate separation is going to change. This component is being taken out. So ID is being just left out with the epsilon A divided by D. And now the factor which has been left out is been dou V by dt. So why don't we take this as a constant value, and this constant value has been taken as the capacitance, the capacity of that capacitance C, and here comes dV by dt. May I know which current it had been? Where we had used Ohm's law, my dear friend. If we would have used V is equals to IR, no, I could have got the current as 0. ID has been taken as IC, the voltage across the capacitance, rather taking V, I had taken VC. Yes. In general, how the capacitance could have been defined? See what I had done. C had been kept one side, IC has been kept one side, dVc by of dt had been brought towards downside. So end of the day, the C which we had received is been IC divided by dVc by of dt. So in generic way, we can say the C would be called as a 1 farad if 1 ampere current had been flowing across the capacitor, if the capacitor had been experiencing the rate of change in voltage instantaneously, and that had been 1 volt per second. 1 volt per second. So may I know how intensified the Maxwell equations were? And even the Maxwell did not been there, no, there should not be in the ID, and definitely there could not be any current ID. And now many of the times you must have seen in network, in steady state we take the capacitor as an open circuit. Why do we so? Why do we do so? My dear friend, in steady state, what does it mean by the steady state? Every transient part has been rubbed out, every transient part has been passed off. Now what had been happening, just focus over here, if it had happened, the voltage across the capacitor is not going to change, and if it is not going to change, what would happen? This factor becomes 0 and ID would become 0, or IC would become 0. The capacitor is not going to sink any amount of current, and this has been the classic example of it. Deeply, if you want to understand what happens, here the voltage V has been placed. Because of V, there had been the movement of electron from here to here, here to here. What happens? As the V is been more stronger, there would be more attraction of the electric charge, there would be more strong surface charge distribution. And as the surface charge distribution had the two plates towards upside and downside, both had been added together. So even the electric field intensity is been rho s divided by epsilon. But one thing has been quite sure. Electric field is directly proportional to rho of s. Rho of s. Yes. And rho of s is been directly proportional to the applied field V. Applied field V. So end of the day, what had been happening, my dear friend? So as V is been changing, E is been changing, and as E is been changing, D is been changing, and as D is been changing, dou d by of dou t is been changing, and you are going to have a current over here. Which current it had been, my dear friend? This has been only one current, and that had been the displacement current. Forget about the Ohm's law. Even inductor would also not satisfy the Ohm's law. Bye bye. Take care.